This is the tutorial for Chapter 8, Section 6, first day on factoring trinomials in this form. So now what we've got, what makes it more difficult, is that we have this term right here, ax squared. A stands for a coefficient in front of x squared, and then we have just the regular bx plus c terms. And so that's what makes this more difficult, because you can't just look at the outer terms and inner terms and see what multiplies to make the last term and subtracts or adds to make that outer term or inner term, because we have to multiply the coefficient in front of the variables to make a different outer and inner terms. We're still going to think of FOIL, and so as we do this, again, I'm going to look at FOIL, and I'm going to know that my first terms need to multiply to make a 5z squared, and my last terms need to multiply to make 14. I also look at this sign right here, and that tells me that I have the same sign. And so since I have the same sign, I look to see what kind of sign it is. Well, they add to make a negative. So the outer terms plus the inner terms are going to add to make negative 17z. And so when I go ahead and set this one up, I'm going to draw two sets of parentheses. I'm going to put 5z and z, because I know those are the only numbers that make 5z squared. I also know the signs, both negative. Now I need numbers that multiply to make 14. And so I've got some different options. My options are this. I've got either 2 and 7, or 7 and 2. And I'm going to actually write that in a little different way. I'm going to write down 2 and 7, 7 and 2. I have to do opposite ways, because I'm multiplying 5 by this term here, one of the factors of 14, and then I'm going to multiply z by one of the factors of 14. And so I have to try both ways to see which one ends up working. My other factors are 14 and 1 and 1 and 14. So those are my different options I've got that would go in place of the last terms, the numbers that multiply to make 14. So as I do it, I'm thinking of trying to get numbers to add to make 17. So I need to multiply 5 by a number that's not going to make it bigger than 17. So like 5 times 14 would not end up working out. 5 times 7 would not end up working out, because those products are bigger than 17. So I'm going to try this one. I'm going to try 2 here and a 7 here, see what happens. So this makes 7z, and this one here makes 10z, and those do add to make 17z. And so you see how that both signs are negative, so it'll add to make a negative 17z, and that would be the answer. So the key is, when we are doing this, is to look at that factor that multiplies to make the first term, and remembering that you got to multiply that by the last terms as well, so it's going to make the numbers a little bigger. So on this one, I see a common factor. I'm going to pull that out first. It'll make the factoring a lot easier at the end. So I go ahead, and I've now got 3r squared minus 5r minus 12. So look for those common factors. So now I'm going to go ahead and draw the two sets of parentheses, because that's how it's going to factor if it factors any further. I know 3r and r are the only numbers that make 3r squared. So now I need numbers that multiply to make 12. My options are 1 and 12. I've got 12 and 1. I've got 2 and 6. I've got 6 and 2. I've got 3 and 4 and 4 and 3. These are my different options. So since this is a negative sign right here, that tells me I have opposite signs. And opposite signs, remember, means subtract. So that means that the outer minus the inner, or the inner minus the outer, is going to equal a 10r, and a negative at that. So just concentrating on getting the outers and inners to subtract to make 10. We'll worry about the sign at the end. So when I do this, I need 3r to multiply by one of the factors of 12 to make it bigger. Make it bigger than 5. And so that's probably what I'm going to start with. And so I'm going to see about multiplying 3 by maybe like a 4. And see, that will multiply to make a 12r. And if it doesn't work out, I'll try something else. And then 3 times 4 are the numbers that multiply to make 12. So I'll put the 3 here, and I'll multiply those, and it makes a 3r. And you see how 12 minus 3 ends up not subtracting to make 5. So I know I did not do that right. So I'm going to go ahead and erase what I just did there and try something else. So I know 3, this form right here was not the right answer, but this might be. So let me go ahead and erase the one that was the wrong one. This was the wrong one. Let me try this one right here. And so I'll put 4 here and 3 here. And so 3 times 3 makes 9r, and here I've got 4r for my inside terms. and those do subtract to make 5r. To make it negative now, I need 9 to be negative. 9 is this one right here, 3 times 3r. So I want the minus sign here and the plus sign here, and that would be the correct form. So looking at this one, the same sort of thing. No common factor here, so I'm just going to draw the two sets of parentheses, put 3p and p. I know this is negative, so that means that the outer minus the inner is going to equal 7p, and it's going to be a negative at that, so just get a 7 to start with. So I've got different factors of 40. I've got 1 and 40, but I don't think it's going to be that since they subtract to make 7. I think it's going to be a little closer together, probably like the 5 and the 8 or the 8 and the 5. But I also have other factors. Remember 10 and 4, 4 and 10. So you've got lots of choices here, and I'm going to concentrate on these numbers right here. Again, because the subtraction is only up to 7, and so that's what the difference is. And so if I put a 5 here and an 8 here, see this makes 15, and this makes 8. And when I do that subtraction, I do get 7. Now, to make it a negative 7, I need to make 15 negative. So the 3 and the 5 need to be my negative number there, and I'll put my plus sign there. So it just takes a little trial and error on these problems. And the key is if you get stuck, start with some factors of that last term. See, 2m, the only numbers that multiply to make it are going to be 2m and m. So I'll put that in there. And then, again, that sign right there tells me outer minus inner is going to equal negative 1m. So I need to get them to subtract to make 1. So I need to break the factors of 15 down. I'm probably going to try 5 and 3. If that doesn't work, then 3 and 5. And if those don't work, then you got 15 and 1 and 1 and 15. So at least list your factors and start somewhere. So I'm going to try multiplying the 2 by 3 and the m by 5. And you see, if I put the minus sign here and the plus sign here, I think it's going to work out. 5m, and then I've got a negative 6m. And yes, those do subtract to make negative 1m. So on this next one, again, we've got a minus sign. That means the outer and inner are subtracting to make 9x. And again, don't worry about getting the sign right first. Just get the subtraction of 9. Get the difference to be 9. So 3x and x are the only numbers that make 3x squared. Now numbers that make 84. Now what comes to mind right away is 7 times 12. And I think one of those forms is going to be it, because numbers have to be close together so that their difference is 9. So I'm going to try multiplying the 3 by 7. 3 times 12 would make it a little bit too big. So I'm going to try 3 times 7 and then put the 12 here, and let's see what happens. See, this is 21x. And this is 12x, and yes, those do subtract to make 9x. To make it a positive 9, I need more positives than negatives. So I'll put the plus sign to make the 21, so the 7 needs to be positive. Put the minus sign right there, and that is our answer. So this next one's a little bit more challenging because we don't have a common factor, and 14 has more than just 2 factors. It's not prime, so that makes this one a little bit challenging. But what is good is that it's a plus sign right here. And when this is positive, that means I know the signs. I have the same sign, and that tells me that the outer plus the inner are going to add to make negative 67k. So I know both signs are negative. That's the first thing I know. Now, since they add to make 67, and 63 is really close to 67, my guess is I need to break 14 down. I'm going to break it down to 2k and 7k. If this doesn't work and I try all the different factors of 63, then I would go with 14k and k. But right now I'm going to try this, and I think I need to break 63 down. I think I need to break it down to like 9 times 7, or it's going to be 7 times 9. And then I have some other factors. You see 3 goes in there, so it could be 3 times by 21, or 21 times by 3. But then you also have the 1 and 61 and 61 and 1. So those are my different options I have. So I'm going to stick with the 9 and the 7 first. So let's see if I put a 7 here and a 9 here. Let's see what happens. So this is 49k, and this one right over here is 18k. And when I go ahead and add those two together, this makes 7 17. I carry the 1, and that does make 67. So it did end up working out. Again, both are negative, so they add to make a negative 67. So a lot of trial and error, but there is some strategy, and the strategy is looking at the last digit sign. That tells us whether we should add or subtract the outer and inner terms, and then also looking at that number. If we're adding and the number's not much bigger than these values, then try breaking down the numbers as close together as you could, like 7 and 9 are close together. If the number is really big, then you're going to end up like maybe 17 here is a little bit bigger than those terms, but they're adding together to make it. So, and again, I have to break those numbers down. So again, if the number is really big, though, like if this 9 were maybe like I don't know, an 80 or something like that, or 81, that would tell me that I probably need to keep 84 as just 84 and 1. So those are types of problems that you're going to end up seeing on tonight's homework. Good luck.